By 2020, one architecture started to dominate language tasks. Language models were transformers, pre-trained once on enormous text corpora. This video walks what happened next. How scale turned those models into instruments you steer with plain text, and how, step by step, they became systems that act. This assumes high-level familiarity with the transformer, and with pre-training, one model, trained once, adapted to many tasks. Here is the road ahead. Scale and the birth of prompting. Grounding a frozen model in external knowledge. Teaching models to follow instructions, making their reasoning explicit, and closing the loop with tools where a text generator becomes an agent. By the end, you should be able to tell this second half of the story yourself and say why this moment matters for research. 2020. The key discovery was that bigger is predictably better. Across several orders of magnitude, the training loss of language models falls as a smooth power law in three quantities: model size, dataset size, and compute. Straight lines on log axes. Shape barely matters, scale dominates. So the decoder branch was scaled. GPT-3 was a 175 billion parameter model, 10 times larger than anything before it. And scaling produced a qualitative change, not just a quantitative one. Place a plain language instruction and a handful of examples in the model's context, and the frozen model performs the task. No gradient updates. The learning happens inside a single forward pass. Accuracy on this few-shot regime climbs steeply with model size. This is the origin of prompting as an interface. The model is steered by the text it is given, not by retraining. Many of the instructions written to models today descend from this result. The honest limits arrived with it. Few-shot performance is uneven across tasks. And training on web-scale text raises contamination concerns. The test set may leak into the training data, and the authors themselves measured how much. Both concerns shape careful evaluation practice to this day. A frozen model has a second problem. Its knowledge is fixed too. Whatever it learned at training time is what it knows. It cannot cite a source, and updating it means retraining. Retrieval augmented generation from 2020 as well addressed this by pairing two memories, the parametric memory in the model's weights and a non-parametric one, an external corpus it can search. The recipe: take the query, retrieve the most relevant passages from the corpus, and generate the answer conditioned on them. Knowledge becomes updatable. Swap the corpus and the answers change, and when provenance is preserved, attributable, the system can point at its sources. The headline: state-of-the-art on 3 open-domain question-answering benchmarks, beating both purely parametric models and classical retrieve and extract pipelines. Grounding a general model in curated external knowledge became a standard pattern, and it is one pattern behind giving an agent a corpus of domain documents to work from. A capable, promptable model is still not a directable one. It continues text, it does not follow intent. The fix has an older root. In 2017, researchers showed that an agent could learn complex behavior from human preferences alone. Show a person 2 short clips of an agent acting, ask which is better, and repeat. Those pairwise choices train a reward model, a learned stand-in for human judgment, and the agent is then optimized against it. With about 900 comparisons, less than an hour of human time, a simulated robot learned a backflip no one could have written a reward formula for. In 2022, the same idea was applied to language models at scale, in 3 stages. First, supervised fine-tuning on human-written demonstrations of good behavior. Second, a reward model trained on human rankings of model outputs. Third, reinforcement learning that tunes the model against that reward. The result was InstructGPT and the family of instruction-following models that ensued. The headline is striking. Human evaluators preferred a 1.3 billion parameter tuned model over the raw 175 billion parameter model, 100 times its size. Alignment with intent was not a byproduct of scale. It was a separate ingredient. Hallucination on closed tasks roughly halved. Instruction following is what made model behavior reliable enough to direct, and directable behavior is the premise of everything agentic. Instruction-tuned models still stumbled on problems that need several steps of thought. Chain of thought prompting from 2022 is a disarmingly simple fix. In the examples you place in context, write out the intermediate reasoning, not just the final answer. The model then produces its own step-by-step trace before answering, and accuracy on multi-step problems jumps. The effect is emergent with scale. Below roughly 100 billion parameters, the chains sound fluent but reason incoherently, and accuracy barely moves. Above that scale, the same 8 examples unlock large gains. Capability was latent in the big models, waiting for the right way to ask. The headline, on grade school math word problems, accuracy rose from about 17% with standard prompting to 57% with chain of thought, state-of-the-art at the time, from 8 examples and no retraining. And there is a second dividend. The written trace can be reviewed, which makes the model's path to an answer inspectable, a property that matters more and more as models start to act. One capability remained, acting. React, from 2022, extended the model's action space with thoughts. The model alternates. A thought, written in plain language, an action, like searching a knowledge base or calling a tool, and an observation, the result that comes back. Thought, action, observation, around the loop until the task is done. Reasoning alone hallucinates. An ungrounded chain of thought can invent its facts. Acting without reasoning loses the plot on multi-step tasks. Interleaved, each fixes the other. On question answering, grounding the reasoning in retrieved evidence cut hallucination dramatically, and on interactive tasks, the same pattern beat imitation learning baselines by over 30 points. And the trace it leaves, thought, action, observation, in order, is an audit log. You can see what the system considered, what it did, and what it saw. At this point, the model is no longer only answering. It perceives its situation, reasons about what to do, and acts on the world, then looks at the result and goes again. That is the definition of an agent, and every agentic system in use today runs some version of this loop. Step back, and the whole decade snaps into one picture. Word vectors made meaning computable. Sequence to sequence mapped whole sentences, and attention removed its bottleneck. The transformer made scale practical, and pre-training made one model transferable. Scale made that model steerable by plain text. Retrieval grounded it. And instruction tuning, explicit reasoning, and tool use let it act. This chain is a selected teaching lineage, flanked on one side by a long prehistory it does not retrace, and on the other by a fast-growing landscape of new techniques forming around agents, sampled here rather than surveyed. And the chain has not stopped. Reasoning models now carry out extended chains of thought internally before they answer, and models are increasingly multimodal, taking images and other data alongside text. The shape of the progression is unchanged. Each step extends what the system can reliably do on its own. 2 moments turned this gradual research into a public event. In November 2022, ChatGPT put an instruction-tuned model in front of anyone with a browser and sent a shockwave well beyond the research community. 3 years later, in December 2025, agentic coding crossed a practical threshold. A frontier model could carry a well-specified programming task about as reliably as a junior software engineer. Much routine coding became something a researcher directs rather than writes. Neither was a new idea. Both were new levels of a capability this chain had been building toward. Why does this matter for research? On tasks that are well specified and verifiable, writing analysis code, sweeping a method across datasets, screening a design space, a capable agent compresses hours into minutes, an order of magnitude, sometimes 2. The gains are uneven and should not be overstated. They shrink where judgment, novelty, or trust is the bottleneck. But the parts of research that reduce to propose, run, check, and repeat are exactly the parts an agent can turn in any field with checkable inner loops. Turning them faster changes the pace of finding things out. This is a reason to attend to this moment, not only novelty, but also discovery. Here is this half of the story on one card. These are the lines worth being able to say out loud. 2020 Scaling Laws and GPT-3, a frozen model steered by text alone. 2020 Retrieval Augmented Generation, external updatable knowledge. 2022 Instruction Tuning, models that follow intent. 2022 Chain of Thought, reasoning written out. 2022 React, reason, act, observe, repeat. And from there, agents. The key idea to carry away: Scale made models steerable, feedback made them follow intent, and tools let them act. Hold both halves of the lineage, from word vectors to working agents, and the present stops looking like a sudden arrival and starts looking like what it is, a chain of removed limitations, still being extended.